We're going to talk about an arithmetic sequence. So a lot of times in math you see sequences, and this just happens to be a special kind. When we did scatter plots, we looked for a correlation. So those correlations meant that there was some kind of pattern there, some kind of sequence with the numbers, and that's what we're looking for today. So here we go. During a thunderstorm, you can estimate your distance from a lightning strike by counting the number of seconds from the time you see the lightning until you hear the thunder. When you list the times and the distance in order, each list forms a sequence. A sequence is a list of numbers that often forms a pattern, and each individual number in a sequence is called a term. So here's an example. I'm counting 1 second, 2 seconds, 3, 4, 5, 6, 7, and 8. The distance is 0.2, 0.4, 0.6, 0.8, 1.0, 0.2. So y'all are seeing a pattern there. This one went up by 1 second each time. This went up by 0.2. Means that your values, okay, basically your dependent values are, because time is independent, that needs to be an arithmetic sequence there. There needs to be a pattern there. But in your dependent variable, you have a constant difference. That means that you are adding the same number over and over again, or subtracting the same number over and over again. In this case, the common difference is 0.2. I added 0.2 each time. We often use the variable a to represent a term. So A9 means A sub 9. It means the 9th term in a sequence. So what I've done here is we're going to figure out how do you find the next term in a sequence. Well, you take the previous term and add whatever your common difference is. So a sub n means any term in the sequence. A sub n minus 1 means the term right before this, and then add the common difference. So for instance, from 2 to 5, we did what mathematically to get there? We added 3. To go from 5 to 8, we added 3. So our common difference here is plus 3. If I want to find the next 3 terms, then I would start with, if I want to find the 4th term, so this is term 1, term 2, term 3. If I want to find the 4th term, then I go back to the 3rd term, which in this case was 8, and I add 3 to it. And that will give me an 11. And then I take that term and add 3 and get a 14. And that term and add 3 and get a 17. And that's just how easy it is. So look at this one. Determine whether the sequence appears to be an arithmetic sequence. Okay, so to go from 3 to 13, I do what? Add 4. 13 to 17, add 4. 17 to 21, add 4. Okay, so first I had to find the common difference, which was to add 4. And now find the next 3 terms. Add 4, 25, add 4, 29, add 4, 33. Just that easy. Okay? The 3 dots at the end of the sequence are called an ellipsis. They mean that this pattern continues. All right, so dot, dot, dot. You see that sometimes in English, you know, and it goes on. Okay? Let's find out if this is arithmetic. Okay? So, from here to here is minus 2. From here to here is minus 3. From here to here is minus 4. Now, I see a pattern, but it's not an arithmetic pattern. Okay? So this is not an arithmetic sequence. We can also find a term way down the line. Alright, so if I want to find the nth term of this sequence, and let's say I want the 500th term, I don't want to take that common difference and add it over and over and over and over and over again until I get down to the 500th term. That's crazy. So there's actually a little formula for that. And it's pretty logical. And basically it says, start with the first term. This a sub 1 means start with the first term in the sequence. So in this case, a sub 1 is 3. So we start with the first term of the sequence. We've got to find out what the common difference was. So to go from 3 to 5, we added 2. 5 to 7 we added 2, 7 to 9 we added 2. So my common difference is 2. So I'm going to add 2, but then how many times do I do that? Well, the first term, I didn't add anything to get to the first term. So to get to the second term, I added 2 one time. Okay, so to get the second term, I added 2 one time. To get to the third term, I had added the 2 times. To get to the fourth term, so plus 2, plus 2, plus 2, I had added 2 3 times. So you can see that I add the 2 one less time than the term I'm looking for. That's what this n minus 1 means. So if I wanted to find the 500th term here, I would have added the 2 499 times. And now that's just a calculator activity. Okay, and I think in this case it's like 1001 would be the 500th term. Okay, you need to know this concept. All right, so find the indicated term of the arithmetic sequence. You might want to pause the video and do that, but here we go. Ready? Start with term number 1, which in this case is 4.2. Since I want the 12th term, 12 minus 1 is going to be 11. That means I'm going to have to add the common difference 11 times. And in this case, the common difference is 1.4. Now you have a calculator activity. So when you do the math, 12 minus 1 is 11. 11 times 1.4 is 15.4. Add those together, 19.6. And that's it.